Welcome back. Question 8. Taking x equals negative 0.8 as the first approximation to a root of the equation, e to the x minus ln 1 plus x squared equals 0. Use the Newton-Raphson method to find to 3 decimal places a second approximation to the root of the equation. 5 marks. Sub 2. Prove by mathematical induction that 3n plus 1 is even for all positive integral values of n. So welcome once more back to the GCE panel online. In this paper, we're looking at the solutions of June 2023 paper 2 pure math statistics, and we are in question 8. If this is your first time to the channel, please look at this subscribe button here. Click on the subscribe button and the notifications bell. Why do you have to do this? Because there are some of our videos which you will not be able to watch if you are not subscribed. You see the video, but you click on it, you will not play because you are not subscribed. And to subscribe is first of all free. You are not paying anything. Okay? Make sure you subscribe before you leave this video. Okay? Next, why do you need to click on the notifications? Because whenever you upload a new correction or a new video, you'll be notified immediately that a new video is available, as you're uploading almost every week, every day. Okay? So you can enjoy all these benefits. Now, equally, make sure you share this video to at least 10 WhatsApp groups, because this is a sacrifice of others that you're enjoying, and we are pleading with you that to encourage us to make more content. If you want to enjoy more, please share this to at least 10 groups or even 20. When you share this, other students will enjoy, and the more we see students watching these videos, or the more we see people subscribing, the more content will produce for you. But if you don't see that, we will know that we are making jazz, and we will stop producing anything to help you. So please make sure you subscribe, click on notification, share on at least 10 WhatsApp groups, and on Facebook and other media. Okay? Thank you so much for being there. Now, let's hit this question hard. So, in this question, we are taking x equals negative 0.8 as the first approximation of this equation given. Okay? So we're going to apply the Newton-Raphson method to find to 3 decimal places a second approximation of this root. So our x0 is negative 0.8, and let our g of x be the equal to this equation that has been given. We have e to the x minus ln 1 plus x squared. Okay? So from here, this implies that our g prime, we need g prime. G prime of x will be equal to e to the x minus the derivative of ln 1 plus x squared will be derivative of the core, that is 2x, all that on the core. So 2x on 1 plus x squared. So that's the derivative that we have. Now we need g prime of what? G prime of 0. So g prime of 0 will be equal to negative 0.08, g of negative 0.08, which is equal to 1.424938. So we obtain this when we substitute negative 0.08 in this g prime function here. Okay? Equally, we need g of 0. Our g of 0 is equal to, g of x0 is equal to g of negative 0.8. And we put do g of negative 0.8, we obtain a value negative 0.045367. So we need g prime of x0 and g of x0 to actually apply the Newton-Raphson method, which states that the second root written as x1, because the first root is x0, the second root is x1 is equal to x0 minus g of x0 on g prime of x0. So this just gives us x1 to be equal to negative 0.8 minus 0.045367. We are making the values long like this for better approximation. All that on 1.424938. And this finally gives us x1 to be equal to negative 0.768. So this is the second approximation of the root. 5 marks. Sub 2, prove by mathematical induction that 3 to the power n plus 1 is even for all positive integral values of n. So there are 2 or more ways to do this proof. Let's look at it this way for this proof. So numerically, we see that 3 to the power 0 plus 1 is equal to 1 plus 1 is equal to 2, which is even. So it's true for n equals 0, right? Then 3 to the power 1 plus 1 is equal to 3 plus 1, which is 4, which is also even, true for n equals 1. Now, Supposing that 3 to the power n plus 1 is even, then we can write 3 to the power n plus 1 as follows. 3 to the power n plus 1 will be written as, because we want to test it now for what? Test it now for n plus 1. We want to check it out for n plus 1 if it's also true for n plus 1. Okay? So we are replacing n here by n plus 1. This will be equal to 3 to the power n plus 1 is equal to 3 into 3 to the power n plus 1 minus 2. So what have we already done here? 3 to the power n plus 1 is the same as 3 to the power n times 3. This is here, 3 times 3 to the power n. From the laws of indices, we'll have just this part. 3 times 3 to the power n plus n will be 3 to the power n plus 1. Okay? Now 3 times this one will be equal to 3. But you have changed the equation here, right? It's supposed to be 1, not 3. Since you have changed it, we subtract 2. Okay? Now 3 times any number minus 2 will give you an even number. Because this 3n plus 1 here, we can see 3n plus 1 is always an even number. An even number times 3 is an even number. Minus 2 is an even number. Which is an even number minus an even number. Because this one is an even number minus an even number, the answer is an even number. Therefore, 3 to the power n plus 1 is even for all positive values of n. So we have proven by induction. There are other longer ways you can do the proof too. Yes. So I take it again. By induction, we test for maybe for n equals 0. For n equals 0, we have 3 to the power 0 plus 1 which equals to 1 plus 1 which equals to 2, which is even. So it is true for n equals 0. Let's test for n equals 1. For n equals 1, we have 3 to the power 1 plus 1 which equals to 3 plus 1 which is 4. Also true for what? N equals 1. If you like test for n equals 2. N equals 2 will give you 9 plus 1 which is 10. It's true, right? Now let's suppose